Good morning everyone. My name is Ankon Dedia. Today I will present MedMO, grounding and understanding multimodal large language models for medical image. MedMO is a unified medical foundation model designed to understand different types of medical images, provide grounded, reliable outputs and clinical tasks. Current medical multimodal images language models have three main limitations. First, they can be unreliable because they do not train on enough medical dataset. This may lead hallucination or unsafe answers. Second, they are struggle with localization, meaning they fail to accurately identify disease regions for anatomical structure and medical images. Third, many models focuses on one imaging such as radiology, pathology instead of learning across all the modalities. To address this, we propose MedMO, a unified foundation model trained on 26 million multimodal samples over 45 medical datasets. MedMo has several key innovations. It is trained exclusively on large-scale medical data covering radiology, pathology, and biological systems and all the others. It uses four progressive training strategies, moving from general vision, language alignment to high-resolution grounding, instruction tuning, and medical report generation. A major novelty is the use of reinforcement learning with verifiable bounding box reward, which improves spatial localization of disease and anatomical regions. The model also supports many tasks including visual question answering, report generation, visual key VQAs, disease localization, anatomical grounding, clinical reasoning, diagnosis classification, and many more. Our dataset is one of the main strengths of the MedMo. It contains 26 million samples over 45 datasets covering major medical imaging modalities such as X-ray, CT, MRI, ultrasound, nuclear medicine, optical imaging, pathology, and many more. It covers multiple body systems including respiratory, cardiovascular, nervous systems, urinary, and many more. This diverse helps the MedMo generalize across different clinical scenarios and medical imaging model domain. MedMo is built on Queen 3VL, 4V and 8V instruct. The training follows the multiple progressive pipeline. The idea is to first build a strong general medical vision language understanding, then improving high resolution localization, then align the model with medical instructions, and finally improves the report generation. These stages approaches helps the model learn both semantic understanding and spatial grounding structures way. For localization, we introduce a novel bounding box reward function. The method uses Hungarian matching to match the predicted bounding boxes with ground truth bounding boxes, which capable of handling the multiple bounding boxes on the predictions. Then the geometric matrices used including L1 normalized distance, generalized IOU. Final reward is covered, normalized and can include penalties for false positive and false negatives. This makes the reward verifiable and directly connected to localization quality. We also adopted cliff higher strategies from DAPO to stabilize the reinforcement learning. MedMo achieves strong result across different medical tasks. For visual question answering, which is 60.3 average accuracy and improving 21.3% over the baselines, and also from text based QA 61.3 accuracies, which outperforming the baselines and Fleming VL. We also have MedMo next versions which produces the most highest accuracy across all tasks. To conclude, MedMo is open source and unified medical foundation model for understanding and spatial grounding. It combines large-scale imitator, progressive training, and reinforcement learning with verifiable geometric rewards. The model achieves strong performance in VQA, text QA, report generation, and grounding, and MedMO improves both disease detection, localization, and it is the most reliable and strongest foundation model in clinical AI system. Thank you.